Hello. Welcome everyone to another episode of your daily dose of LeetCode live streams. Starting off strong today, I see that we have some new viewers on the chat. We have Chich and we also have Voldemort, so thank you so much. I always love to see new faces. I really hope that for the both of you, your LeetCode journey is coming along well, and I'm really happy to have you here. I hope that these help you stay accountable and at the very least offer some entertainment from the grind that we all know is so hard. So let's just do some quick sort of housekeeping here. So remember, you can visit rafaelslist.com, which I try to be diligent with and update frequently. And by frequently, I mean pretty much every day after my stream. So remember that for each one of these different ones, you can go ahead and click on the LeetCode question link or the stream clip link that will take you to a chapter in an existing stream where I talk about the question. And something new that I added actually as of yesterday is the ability to keep track of the questions completed. I realize that I currently have no way of notifying the user that they can actually click on this. That's probably something I'll be releasing very soon. But anytime you click on one of these, you'll notice this progress bar up here increase. So it's just a nice little indication that you're doing something, and also a nice way for you to know what questions you've actually completed so you don't end up doing them again. So just wanted to bring that out. Also, I have links to all these things in the descriptions for the streams, so I hope that that's an easy way for you to find everything. So yesterday we ended off again on page 2, and we're currently sitting at 164 questions. So we'll go ahead again, starting from, let's see, what's going to be the first question today? Smallest range number 1, and we're off to a terrible question as our first one. But we're gonna try and do it. What I'm gonna do from now on, like for any one of these questions that are, if they're like rated really poorly, what I'm probably just gonna do is I'll spend some time with it, but after like 10-15 minutes, especially for easy questions, I'll probably just skip them. Because really, like my rule is I want to try and do as many top quality questions as I can, and also we have that other rule that even if we skip some now, we'll never go to medium questions until we do every single easy one. So rest assured, we will get to our goal. Voldemort asks where I'm from. I'm actually from Florida. Where are you from? I love to just like interact with the audience, so really appreciate the questions today. It's pretty neat to think or to see. At some point I was just doing these streams, and for like a couple of weeks I wasn't like having anyone, so it's very cool to have people chatting with me now, and that's something that I really do appreciate. So, oh nice, Queens, that's very cool. I actually just visited New York. Well, not just visited, but we went, when I say we, I mean my girlfriend and I, we went for a work trip of hers, and yeah, we had a really good time. Like I hadn't been to New York in a long time, so just being able to walk around like Times Square. We went to like this amazing steakhouse called Gallagher's, and that was like phenomenal. So yeah, New York really knows how to get it done. Okay, sweet. So let's see what this one has to offer. So you're given an integer array nums and an integer k. In one operation, you can choose any index I, where 0 is, where 0 is less than, I nums I length, and change nums I to nums I plus x, where x is an integer from the range minus k to k. You can apply this operation at most once for each index I. The score of nums is the difference between the maximum and minimum elements in nums. Return the minimum score of nums after applying the mentioned operation at most once for each index in it. How do we, so nums is 0, 10. Integer k, you can choose any index, 0 to less, and change nums I to nums I plus x, where x is an integer from the range negative k to k. Okay. Change nums to be 2, 8. The score is max of nums minus mins of nums. The smallest range. Okay, so from negative 3 to 3, we can pick any k, and we can add, so what did they pick here? They picked, for each one though, so from negative 3 to 3, here they pick 3, here they pick 1, and here they pick 4, because it's 0. So you want to try and minimize this. So from negative 2 to 2, what number can I pick here? If I make this a 2, okay, and then this will be 8. Okay, so it's like increase, let's see, the maximum is the max minus the min. So increase the smallest one by some factor and decrease the largest one. Is that what I'm getting at here? Smallest range? That's just like what it seems though, and I realize that might not be, because the smallest range could also be like, let's see, change those to be 4, 4, 4, right? Like this 4 might not be referring to it could be referring to like if this is 0, 10, and 20, it should just be, I think, the first two numbers, and that's how we can get the minimum score. I think. Like what if we sorted these numbers? Oh, nice. Look at this. I am from New Jersey but work in New York City. That's super cool. Yeah, for anyone, like, let me actually make sure I have my alert boxes all set up here. Okay, I do. Like, is anyone coming? Can you guys just drop a comment? Let me know where you're coming from. Are you all coming from YouTube? Are you coming from Twitch? I'd love to know, like, how did you all find me? And yeah, just to like get the conversation going. I want to see, I'm curious like where most of my viewers are coming from. All right, so what I want to try here is, what if I sort it and just apply this like for anything in the range? Like, let's say I'm gonna come up with some example like 0, 2, 6, and 8. Now, if my range, but this negative k to k, and let's say, I don't know, k is like 4. So I can add, like here I can add, I don't know, 4. On here I can add -4 or 4 or some other number to make this like really low. Let's think about this. If I added -4 to this, it would be -2. And then I can also add, can we add, if we did -4, if we did 4 here, choose any index I where I is less than change nums I to nums I plus x at most once for each index I. The score of nums is the difference between the maximum and minimum elements in nums. Turn the minimum score of nums. Oh, I see. Okay, so 4, 4, 4, it's 0. So we really just want to try and minimize them. So can we make them, what's the closest they can be? This is the least and this is the maximum. This is the least and this is the maximum. Should I just try and take like the least? Like I can make this 4 and I can make this 4, right? Because here I can add 4 to make this 4, and here I can subtract 4. Right, 8 plus -4 to make that 4, and that would just be 0. So I'm wondering if it's like, what's the closest that I can get? Can I actually just do that? 0 and 10, I add 2 here, I subtract 2. 1, the score is max. Nums minus min nums, output of 0, k equals 0. It's a weird case when it's k 0. Yeah, I'll figure out what happens if we have like a single array, but I feel like let me try and sort this first. So let's do sorted nums is equal to nums dot sort a b a minus b. So this will give us a sorted array. And now what if I just took the first index and actually something else that we can do, because right now this is n log n to sort, but we can actually do a little bit better here. I can say const min is math.min of nums, const max equals math.max of nums, because this is going to run in linear time. So this is just linear versus n log n, which should help us a little bit on time complexity. Now we have the min and max number, and we have this k range. Like, what if to the lower one I just added -k, right? If this is 3, I can add 3 and then subtract 3. So what if we did, and then we just have 4 minus 4. So const lower equals min plus k, const higher equals max plus, or I guess max minus k, right? Can we just return higher minus lower? But what's going to happen if it's a single array though? If it's a single element, we get the min and the max, which is 1. Do min plus k, so higher minus lower, that's just 0. So what do we got here? 0, 6, -1. Oh man, okay, kind of close on this last one, but let me see. So Queens, YouTube, Montreal. I found you on Twitch. It's hard to find you on YouTube, but your stream shows up on Twitch if you type LeetCode. Yeah, I think maybe that's why you were telling me the other day that I should focus on Twitch. Yeah, like for some reason my streams don't get saved on Twitch. I thought like if I streamed, it would necessarily be saved to like my library. Maybe I have to do something on Streamlabs to make it so that it stays on my Twitch channel. But I'd love to hear like any feedback you have. I know you already told me that I should focus more on Twitch since it seems like a lot of people are there. But yeah, any other feedback you have, let me know. Chich, like because you're coding in JS? GS. Are you saying that you like that I'm coding in JS? Or do you mean like thumbs up because you're coding in JS, which I guess implies the same thing anyway. Okay, so what happened in this last one here? So I took the min, which is 1, and the max, which is 3. I added 3 to this one, so 1 plus 3 is 4. 6 oh, okay, I see. 4, 4, 4. So this doesn't necessarily have to be. Score is max nums minus. Now here, yeah, we can also add 1 to here, for example. So, I mean, should I just try to get them all to be... If we just like add... I mean, does it even need to be like the... Because like it could just be the next one, right? What if I try to get these really close to each other? I can add 1 to this one and subtract 1 to this one. Right, because 2 is in this range, or 1 is in the range, and negative 1 is also in the range. That will each equal that. So it doesn't even need to be... It doesn't necessarily need to be k, right? If I subtract 3 from here and add 3 to here, that'll be fine. If I subtract 2 from here and add 2 to there, I also don't know if it has to be like the second. Well, I guess it's kind of the same, right? Here, if I do, what if we do it from the back? Let me try sorting it again. There's one thing I want to try. Like if I do sorted equals nums, we're going to try sorting this again. A, B, A minus B. All right, let's get, we can say max is equal to sorted. That's sorted.length minus 1. Let second max equals sorted. That's sorted.length minus 2. I realize this will fail for an array of size 1. Now if we just add, right, because in this one, again, this is a very contrived example. Like I'm focusing probably too much on this one. So if I add 3 to this, again, if I do minus 2 and plus 2. So what if here for the max, for the lower one, I can add min plus k, higher is max, or second max. Second max should be my lower, or no, wait. Second max plus k, which would be 0 plus k is 2. Higher is max, which is 10 minus 2, okay? And then here, minus 3 and plus 3, that's 6. Oh, but then that becomes 3 though, right? Strange question. Yo, what's up, Marvin? Yep, you're one on the rare people that code in JavaScript on LeetCode and stream. Keep it up. Oh, thank you so much, man. That's like super encouraging. Yeah, I mostly code in JavaScript because I lean front end and I do a lot of front end stuff at work. So I really enjoy the language and it's cool. That's weird though. I thought there were like more people that did JavaScript stuff, but if I'm the only one doing it, then hey, that's good, right? That's good for all of us. Why? I wonder why this one's so bad. Return the minimum score of nums after applying the mentioned operation at most once for each index in it. Maybe I should, let me spend a couple more minutes on this one again because I don't want to, the previous streams we haven't been doing many questions, so I want to make sure that we're solving like a good quantity of them for each stream. We have 136 and the range of possible numbers, right, is -3, -2, -1, 0, 1, 2, 3. And I have my max and I have my min. So like the smallest range I mean, it could just be any two numbers that are next to each other. K is 0. So like if I get to 1 and 3, 3 minus 1 is 2, which is inside of that range. So like if that number is inside, maybe it's just 0. Now 0 to 10 and K is 2. So if it's 0 to 10 and K is 2, I have all these available to me. Negative 2 to 2. You go to 0. And then I have a 10 that's outside of that range. Three, okay, and then 1, 3, 6. Kind of just like thinking out loud here. 1, 3, 6. 1 and 3 are both within the range. So if I have two numbers that are within the range, maybe like if I have two neighboring numbers, like 1 and 3. 1 and 3 are within this range of negative 3 to 3. So maybe that's why it's 0, because that means that I could find, like I could just subtract 2 from 3, and that's okay. 0 and 10. Like these are not in the range. Like 0 is in the range, but 10 is not in the range. And what does it mean if 10 is not in the range? Why would I want to subtract 2? Is it because I'm trying to put it in the range? Squares max nums minus min nums. 8 minus 2 equals 6. 1, 3, 6. And even if I just took 4, 4, 4, these are not all within the range though. 3 and 6. And why would I change that to 4 from 3? 3, 2. The distance between 1 and 3 is 2. This is 3 to 6. This is 10. That doesn't really give me any hints. Well, like I said earlier, I feel like I thought this would be a good question. For some reason, I saw the name and I'm like, oh, this is going to be a good question. Now it's rated poorly, but that doesn't always mean that it's because it's like hard or anything. It might just mean that it has a lot of crazy edge cases. Let's look at like one of the related topics. Okay, array and math. So is this something that's like math related? Maybe that's why people don't like it, because math questions don't really come up very often. What range exactly means in that case? What they want to see is like you're given this k. So for example, if k is 3, these are the range of numbers that you can apply to each one of these. After you apply one of these numbers to each one of these numbers, what's the smallest range that you can get? So for example, here, what they did is like, okay, in the first one to make it 4, there's a 3 in the range, right? So we can add 3 to this one to make it 4. For 3, there's a 1 in the range, so we can add 1 to make it 4. For 6, there's a negative 2 in the range, so we can add negative 2 to make it 4. And now the smallest range is 0, because they're all the same. Like 4 minus 4 is just 0. So it's a little bit strange. I am gonna skip this one since we're already at 20 minutes for this easy question, and I really do want to try and get more quantity this time. I might stream a little bit longer just to make up for the fact that these past days haven't been as productive as I would have liked. Let's check this one. Check if matrix is an X matrix. Give us okay, this seems maybe like a high quality question. Okay, cool. A square matrix is said to be an X matrix if both of the following conditions hold. All the elements in the diagonals of the matrix are non-zero, and all other elements are 0. Okay, this is interesting. So there's definitely like, and what's the size of this? Grid dot length 100. It doesn't really matter, but any of the corners. Can we just make sure that? Oh no, but this is a bad example here, because all the elements in the diagonals of the matrix are non-zero. Diagonal are non-zero. And all other elements are 0. There's a little bit of a pattern here though, right? Because a diagonal, let's write the diagonals here, right? Like if we go down this way, diagonal always has the same row and column. I think that's something we can do, like, right? Like anytime row and column. No, it's not. No, it's not. Oh, wait. Oh man, I was so excited. I was like, man, we're about to get lucky here. No, but there is something that we can do. Like we can check to see 001122. So we always know, like for any of these, let's see, oh, this, so it's only these. Man, that's a tease, man. I'm thinking of coming up with some like mapping, or I'm trying to see if there's a pattern that we can use to draw up like a nice for loop. Now I'm curious here, like if there was another row and another column, how would that look? I'm trying to figure out how that would look. Would the zeros always be on the edge like this? Is it always just going to be... Okay, let's see. A 0, like it's never going to be on the corners. Like 0, 0, or 0 at grid.length minus 1, or grid.length minus 1 of 0, or grid.length minus 1, grid.length minus 1. Like these coordinates, the corners should always be non-zero. So like in our loop, if we ever get to something like this, we know that should not be 0. And then the ones that are 0, looks to me like will be like anything. Let me see. This could be like one case, like, okay, we check to see if this is 0. Now the only ones that are not 0, because this is going to be at least 3n. It's a square of n by n. It's always going to be at least 3, so it's always going to be at least this size. 0, 1, 2, 3. Or this one actually. The grid is not an X matrix. I feel like if I always know it's going to be that size, I wonder if we can say like, let me see, this is 1, 2, 1, 2, 0, 1, 2, column 0, 1, 2, and row 1, 2. So like columns, anything that's row 0 with columns of 1 or 2, or 1 through length minus 2, or something like that, should be 0. Over here, or is there a way that we can just scan the array this way? 0, 1, 0, 0, 0, 0, 0. Okay. Yeah, I really feel like that's what I want to try and do. Like, we know that the edges will always be 0. I think that's kind of like, that's what it should be. All the edges that are not corners should be 0, and everything else should be a number. So maybe that's like what we can say, like if this is an edge and not a corner, it should be 0. Else it should be non-zero, right? So like this is an edge, but it's a corner, so it should be non-zero. Okay, now this is an edge, but this is an edge and it's not a corner. Edge and not a corner, edge and not a corner. Oh, this is an edge and a corner. This is not an edge and it's not a corner. If at any point either one of these is not true, then we can just return false. So if it's an edge and it's not a corner and it's not 0, if we are at an edge and not a corner and value is not 0, return false. else if we are at a 0 value, return false. I think we can maybe get away with that. So I'm gonna do a normal like nested for loop here. We're gonna iterate throughout the entire grid. So row less than grid dot length, row plus plus for let column equals 0, column less than grid row dot length, column plus plus. Let's see if we can put these to the test here. Okay, so now let's figure out what an edge is, right? An edge, what is an edge? What is an edge? An edge, if row is equal to 0, right? Or column is equal to 0, or row is equal to grid dot length minus 1, or column is equal to grid of row dot length minus 1. So I'm going to make a function for this, and we'll say const is edge, where we take a row and a column. Right, the time complexity here will be quadratic, correct? At least this is the first iteration of my algorithm, because I feel like we probably have to go through every single element to know, right? Because we have to know if some are 0 or not to be able to tell. So I think because of that, it's fair to say that it might be n squared. Okay, so this function here is going to return if given a row and column, if this is an edge. So if row is equal to 0, or column is equal to 0, or row is equal to grid dot length minus 1. And let me space this out a little bit to make it easier to read. Or column is equal to grid of row dot length minus 1. Okay, so that will just return true if either one of these is, right? If either one of these is true, it will return true, and that's how we know if it's an edge, right? Because if row is 0, or column is 0 here, or row is equal to grid dot length minus 1, or column is equal to grid dot row dot length minus 1, which is this last one. Okay, so if it is an edge, oh, and let's also do, let's do is edge and is corner, row column. So we have a couple of different ones here, right? Because the corners can be 0, 0. Oh, I had that earlier and I messed it up. So it can be 0, 0. It can be 0, grid dot length minus 1. It can be 0. That's for that other one. It can be, yeah, grid dot length minus 1, grid dot length minus 1, or row grid dot length minus 1, 0. So given a row column, is it, so I guess we can have many cases here. If, let's see, so return if row is equal to 0 and column is equal to 0, or we can say row is equal to 0 and column is equal to grid dot length minus 1, or row is equal to grid dot length minus 1 and column is equal to grid dot length minus 1, or row is equal to grid dot length minus 1 and column is equal to 0. Okay, so if we're at an edge, so what's our algorithm here? If we're at an edge and not a corner, so if is edge row column and not is corner row column, and value is not 0, and grid of row column not equal to 0, then we just return false. Or what do we say? Right, and for everything else, if row column, oh no, that should be else if, right? Return false. Let me actually do the curly braces here to make this return false. Else if grid of row grid of row column not equal to, or equal to 0, return false. Let's go over this real quick here. Let me remove all this stuff. Let me remove this. Let me remove this. So if we're at an edge, like what happens here? So we say, okay, is this an edge? Yes, it's an edge. And not is corner. This will be false, so this whole thing returns false. If this is equal to 0, we return false. But no, we get to 2, and that's fine. So we come to this next one. We say, is this one? Is this an edge? Yes. Is this not a corner? Right, it's not a corner. If grid row value is not equal to 0, that's false. Else if, oh, but wait, no. I think we should always be, yeah, because I don't want it to go to this else if this is not true, right? Return false, but now, do I just have to write like another one that's not equal to 0? I'm getting stuck with like the simplest thing here. This is like, I feel like we figured out the hard part. Now it's a matter of like, I only want to, like I want to check if something, if this is an edge, if we're at an edge and not a corner and value is not 0, we can return false. Else for every other one, we just want to make sure that it's not if grid row column equal to 0, but then this will fail, right? Because this is an edge. Yes, it's not a corner. And grid row column not equal to 0. That's false. This does not execute. Else if grid row column. I mean, do we just put another, sometimes I get like really confused with these, but let's try this. Will this work here? If I get here, this will return false, but then I also get if grid row. Maybe here it can just be, if, I guess here we can just have the same thing. Maybe we just do this. If it's an edge, no, but then we don't need the corner, right? It's only have to be, but if the matrix is like 5, 5, will this work? Let me see. Yeah, how would that look if it was, 5, 5? You know what? We might have to, I wish there was like an easier way for me to draw like tables here. So if we have, right, 0, 1, 2, I think you mean something like this, right? Because how many do we have here? 0, 1, 2, 3, 0, 1, 2, 3. No, so I don't want this last one here. So we put, what, 4 in there? All right, there you go. So I think so, because this will still be 0. All these diagonals are like, would this be 0? Or is it just diagonal? I think I know what you mean, because is it saying like, okay, this should be 0, that should be 0, that should be 0, this should be 0, 0, 0, 0. No, that shouldn't be 0. This should be 0, 0, 0, 0, 0, 0. Now diagonals should be non-zero. Let's say 5, 6, 7, 8, 9. But like, okay, so this one should be 0. I'm confused. Like, should this one be 0 here? Or is that like, I guess diagonal only if it, I mean, I guess you can argue that any of these are diagonal, right? So I guess the diagonal necessarily has to start from a corner. Oh, okay, nice. That's good to think of it like this. So perhaps, I'm actually happy that we thought about this, because that means that there might actually be an even easier way of doing this. Maybe this is too, maybe. Because what does that mean? That means there has to be a pattern then. How do we know? Is there a number? I think we need to write down Let's do this. Let's take a 0, 0, 0. We should probably write the pattern for zeros. Like the zeros in the first row appear on, let's see, column 0 or row 0, column 1, 0, 2, 0, 3. On the second row, they appear on row 1, column 0. Oh, wait a second. No, okay. I almost thought I came up with some pattern here, because these were like on the outside, but then these are on the inside. These are on the outside. It's getting tricky. Could we do something like, what if we look at this? What if we look at the diagonals here? 1, 2, 2, 3. Like how many, like this first diagonal, if I'm going this way, right? And let me draw an arrow to show you what I'm doing. Like I'm counting like this way. If we start down here, we have like no zeros and one non-zero. Then we have 2 zeros. Then we have 2 zeros and 1 non-zero. We have all zeros, all non-zeros, all zeros. Like, could we use that to our advantage? 2, 1. So we should have 0, 2, 2, 4, 0, 4, 2, 1. Or 0. 0, 2, 2, 4, 0, 4, 2, right? 2, 2, 0. I don't know if that really helps, but like if there was a way to say like, how about over here in this one? We have 0, 2, 2, 0, 2, 2. Does it just converge? Like this first one we should have 0, but we have 1. How would we know when we're already? Maybe we could do. The arrow looks good on you. Thank you, man. Maybe we should. I don't know if that will help us. Like if I just check every single diagonal, and then for every single diagonal we come up with this thing, like, and the diagonals that are from, like we can start at the middle one here. Okay, what if we start at the middle diagonal? What if we start in the middle diagonal? We know the middle diagonal should have no zeros, right? And then the diagonal to the left of it should have 4, which here is length minus 1. But then why do we go to 2 and 2? Like, what's the pattern there? I think this is too small of a, it might be too small of a table to like know the pattern. I'm not even sure if that's like the best way to go about this one. 0, 2, 2, 4. Is there another way? Let's see if we can look at this for like a little bit longer. An X matrix. What if I just, could we do like a spiral traverse or something? Like spiral here and then spiral there. 0, 0, 0, 0. We should just have 1. Go inwards. Maybe we cut it in half. You mean cut it in half on the diagonal, right? So like we have like here, I'll do this to signify it because I can actually, yeah, maybe we only consider like all these right here as 1. Like all those, anything that the line goes over is 1. This is like, this thing in the middle is our diagonal. We don't have to like touch that because we know that's going to be true. Or when I say true, it should have all non-zero numbers, and then this will be like another one that we inspect. Maybe. But like, what does that give us? Actually, how many zeros are in this half? 1, 2, 3, 4, 5, 6, 7, 8. I don't know how helpful that is. Square matrix is said to be an X matrix if both of the following conditions hold. all the elements in the diagonals. I mean, how about, wait a second. What if we just check all the elements in the diagonals of the matrix are non-zero? Wait a second. What if we just check the diagonals? You know what I can do? I can check the diagonals easily, right? Because even if it's a 5. Oh, wait. But this is still not. For any, yeah, I guess for any square grid. Yeah, okay, what if we try to do this? What if I write a function to check both diagonals? That's going to already tell me if it's like, if every single one of them is non-zero. But what if I also write, let me see, 1, 1, 2. What if we also just like store the coordinates that we've already been at? And then we like loop through everything again, and for every coordinate that we hadn't checked, it should be 0. Something like that. Maybe we could do that. Not sure how fast that would be, but I want to give that a shot. Okay, like let's do check top left and then check top right. Check top right. So what if here we did the same thing for let row equals 0, row less than grid dot length, row plus plus. For let column equals 0, column less than, oh, it can also be grid dot length because it's square. Column plus plus. If grid of row column is equal to 0, right? At any point if we come from top left, if it's equal to 0, we return false. Now, how would the one on the right look like? We can say the row is equal to 0 and the column is equal to grid dot length minus 1. Column should be greater than or equal to 0. Column minus minus. Although this is not actually going to check. Yeah, this is not going to do. I probably need to do like a while loop here. I need to do 0. Yeah, let's do that. Let row equals 0, let column equals 0, while row is less than grid dot length and column is less than grid dot length. Could just do this right here. Right, we'll do false, row plus or equals 1, column plus or equals 1. All right, we'll increase the row, increase the column. That's top left. Now for the same thing. This is gonna look a little bit verbose, but I'm just trying to solve the question. So row now will still equal 0, and column will be grid dot length minus 1. Here we can say while row is greater than or equal to 0, and column is greater than or equal to 0. So if grid row of column is equal to 0, return false. We want to do row plus or equals 1 and column minus equal 1. All right, so we're going to increase row in both cases, but starting this way, we'll go all the way down. Now row should be less than grid dot length. Row equals 0, column equals grid dot length, while row is less than grid dot length and column is greater than or equal to 0. If grid row column equals 0, return false. We can increase row and decrease column. Okay. Now, what's the best way for me to like store these? Just to say that I've seen them. I don't want to have to like generate a key every single time. But what we could say is now like anything that we haven't already seen, anything that's not in that diagonal. Could we have like a set for row and column? Will that make sense? Or is it better for me just to do trying to think of the best way for me to do this. Rows and columns inside of each one. For every row, I pair it with a column. So what if I had something like let scene is this. So I can say scene of row yeah, this is kind of strange, but we can say if I haven't seen, let's see, if scene of row is equal to undefined, I'm going to say that scene of row is equal to, now how would I be able to add that in there? No, that's not going to be nice. If I've been to that row and I've been to that column, so at any point we have to have row and 0. We could have like sets for each of these, but it's not. Let row set equals new set. Let column set equals new set. Maybe for each one of these, yeah, not like, this is really not my favorite solution, but I just want to see if this will get us to be able to solve this. We're going to do the same thing over here. And now, sort of like the end, what we can do is we can do row equals 0, row less than grid dot length, row plus plus, for let column equals 0, column less than grid dot length, column plus plus. So if not row set dot has row and not column set dot has column and grid of row column. So if we're at one of these and it's not equal to 0, then we return false, else we return true. This is wild here. I think there's a pyramidal pattern for the non-diagonal. Right, no, there definitely is. Like, and it's especially clear with like this drawing here. It's just like translating that into code and even trying to figure out like, is that the most, like, is that gonna get just really tricky? But let's see what this gives us. And then I'll explain everything I did once I'm done, because I feel like I just wrote a ton of code. Okay, let row equals 0. It doesn't like that I'm redeclaring it here. True and true, okay. Sheesh. Yeah, for real. This is like, sometimes I think to myself like, man, are these questions like actually easy? That's why I can't, like, people don't give easy questions enough love, man. You can get so much out of easy questions. Let's see, I passed 2 test cases. Does that necessarily mean it's going to pass? Let's see, here we go, submit. Okay. True and false. I wish there was like an easy way for me to write this out. How many test cases did I pass? 42 out of 84. So literally we passed half of them. So 5001 0415. Okay, so that one should have failed. So I think it has to do, probably has to do with one of these here. Because this is only going to do the diagonals. It'll add them into the row set and the column. These are just the rows and the columns I've been to before, but maybe there's a better way for me to... You know what I could do as well? You know what I could do actually? I have an idea. What if instead of doing row set, and call set, what if we just changed the number at that location so that we know that we've already been there before? Like here we're just checking diagonals, right? If it ever is equal to 0, we automatically return false. And then for this one, all we need to do is for every grid, for every cell that's like not -1, for example, what if we do, because this is a trick I see a lot. What if I do like grid row column equals -1 and grid row column equals -1. So here I can say if grid row but that wouldn't make sense, right? I only want to consider the ones that are not. If it's -1, I've already been there, so I don't need to check that anymore. So I just need to make sure that the remaining ones that are not. So if grid of row column is equal to -1, continue. If grid of row column is not equal to 0, return false. Put this up here. Let's copy this real quick. This is like a trick I see a lot in other problems. Let me see what happens here. True, false, false. Okay, so we got false that time. So it did pass the test case. Let's submit it again. My acceptance rate is starting to go down after doing so many easies. Okay, 63.72. Cool. Yeah, it's a little bit strange. I'm happy that we solved it, but it's a little bit strange. Let me try something though. Let me submit it again and see if I'm on like the lower end or the upper end. Okay, so it looks like it's trending downwards. Yeah, like nice that we solved it, but I don't love the way I solved it. Let me see. Row +1, column. Yeah, it'd be nice if I just said like incrementer. The only thing changing here. Maybe we can do something like function check diagonal. Row is less than grid.length and column. Oh, that's gonna be, nah, this is not something that we can easily make into a function. Okay, so what is it that we did, right? Like here, we just first immediately check the diagonals. And is there really no pattern to what a diagonal is? Like, does a diagonal has to have, that's the thing, because it doesn't, like a 0 can also be a non-edge. But what does a diagonal have? There's got to be something unique about the coordinates of a diagonal. Like 0, 0, 0, 0, or 0, 1, right? We know those are some of them. Or 0, 1, 2, 3, 0, 1, 2, row 1, row 2, column 1, row 3, column 0. Is there anything unique about these that is not the same with the other ones? No, I'm not sure. Not off the top, at least. What is it that we did here? So I checked the diagonals first. I just have a loop that goes from top left to bottom right, and then a loop that goes from top right to bottom left. If any of those are ever 0, then we just return false. But in the meantime, we're also setting visited cells to equal -1. That way, at the end, when we go through our whole array again, if it's a -1, we don't even consider it. That way, we only consider cells that we haven't seen already. If at any point those are 0 or not 0, we also return false. Kind of weird, but hey, at least we solved it. And that's like, for a question like this, let's see what the discussions are. I guarantee you it's something that's super simple. Like the not diagonal or like pyramids, it goes like, yeah, no, it definitely does. Like I really see that, but like, let's see, 0, 0, 0, and then it goes out, and then it goes like in, but it's like weird. Like, how do we write a pattern for that? Are we doing like middle here and then some other odds? Like, it looks like, to the human eye, it looks like something like, oh yeah, we can find a pattern for this, but writing it in code seems weird, seems tough. Let's see what the discussions say here. One pass. Yep, this is what I was scared of. It's going to be an easy one pass solution. Here we go. Okay, so see, so I feel like I was kind of close in saying, let's see, this is a standard row column. If I is equal to j, so if at any point I is equal to j, what does that mean? If row column are the same, okay, is that, oh, I guess that's just a 0. Or I row plus column equals g size minus 1. Oh, wait a second, is that the pattern here? That pattern that we wrote? Oh, look at that. Wait, row plus column here is 1. So that's not 0 plus 1 is equal to g size minus 1. Return false, return true. If gij equals 0, so what's this one for? I plus j equals g dot size. If I equals j, row 0, column 1. No, I think I messed that one up. Yeah, I think I messed that one up, right? This should be 0, 0. This should be 1, 1. Okay, whatever, 2, 2, 3, 3. Oh, I equals j are the columns going down this way. Is the diagonals going down this way? And then row, oh yeah, row 1. Okay, the diagonals going this way will always equal size minus 1. See, so you're right. Yeah, that's the hard part, finding that pattern. But yeah, this is considering the diagonals. If those are 0, you return false. Else, if it's not a diagonal and it's greater than 0, return false. So I almost feel like the first thing that I was doing was kind of on the right path, but then I kind of just got like caught up with it. And so yeah, I think so these like 2D arrays, there's some questions that are pretty interesting, like having you traverse arrays in very unique ways. I think this is one of those, like you have to know how to traverse a two-dimensional array, or find some pattern like we did here. But now we know this is something that I think we should pay attention to. Diagonals this way, their coordinates will always equal the size minus 1, and that could be helpful in the future. So I'm going to like this one, and I'll also make sure to add it to my website afterwards, but that was pretty good. Prime number of set bits in binary representation. Anything with prime numbers I don't like. Given two integers left and right, return the count of numbers in the inclusive range. Having a prime number of set bits in their binary representation. Recall that the number of set bits, okay. Is there like, I'm gonna just do something here. Like, is there a function to check if a number is a prime number? So JavaScript function for number, prime number. Is there just like, because I don't know, I haven't dealt with prime numbers in such a long time. What's like the easiest prime or not in JavaScript? So it has to be this every single time. For var I equals 2, I less than num, return false, num is greater than, return num greater than 1. So what we can do, I mean, for each one of these, there's a formula, or like I guess an algorithm that's called Hamming distance, or the Hamming weight. That's a log n algorithm. So I mean, we can apply that every single time. And this, I guess this prime or not in JavaScript seems like it probably takes what, like n? It's pretty much like n in the worst case. It's going to have to go through every single number. So it seems to me like this will be an n log n algorithm. Should we try it out? Call the number of set bits given two integers, however many of them are prime. Ooh, I want to try something crazy. Like, can we reduce this? No, it'd be nice if we could, but let's see. Let primes equals 0 for left less than or equal to right, left plus plus. Let's see, const calculate Hamming distance of num, or I think it's Hamming weight. So let Hamming equals 0 while num not equal to 0, hamming plus or equals 1, and num equals, I think it's like num and num minus 1. This is literally just something I memorized. So don't feel like don't feel like, oh, you know, he's a genius, like he knows this. No, I just memorized this one day. This is just how you get all the set bits given a number. It's called hamming weight, and I highly recommend you know how to do it. So here we can just return hamming, and I think what we can do is, I guess I'm just gonna copy this because frankly, like I really just don't know about prime numbers. So const is prime. This is just a num. Let's see. So let's do this. Let's do that. Let's do this. Let's do this. We'll do for let I equals 2, I less than num. I plus plus if num modulo I is equal to 0, return false, return num greater than 1. So here we can say if is prime, calculate hamming weight of left, primes plus plus, return primes. Let's see what this does. 4 and 4. Four, 5, 4, 5. Submit. 93.94. There you go. All right, I take no credit for this one though. The only thing I knew was the hamming weight part. This prime thing, I should know how to do this. I don't like when I think prime numbers, I'm like, okay, yeah, I guess it makes sense by definition. It's like only divisible by the number and itself, or 1 and itself. Is that what it is? How can I forget what a prime number is? It's only divisible, not a product of two smaller numbers. Okay, this is like a crazy definition. Can we just get our 1 and itself? Okay. So if any other number is equal to 0, then return false. Okay, so that makes sense. Yeah, I'm sure there's probably even like a way better way of doing this. This is probably like a terrible thing. Like I'm not like I'll take the win, but at the same time, I didn't learn anything by doing this question. So let's just pretend. Well, it did happen. Let's not pretend it didn't happen, but let's just continue going here because I think this one sounds fun. Unique email addresses. Okay, let's see this one. I feel like I remember looking at this one a long time ago. Every valid email consists of a local name and a domain name, separated by the @ sign. Besides lowercase letters, the email may contain one or more period or pluses. For example, in Alice is the local name and LeetCode.com is the domain name. If you add periods between some characters in the local name part of an email address, mail sent there will be forwarded to the same address without dots in the local name. Okay, if you add a plus in the local name, everything after the first plus will be ignored. This allows certain emails to be filtered. Note that the rule does not apply to domain names. Interesting. So it's going to be a lot of string splitting and index of sort of operations here. Like in this one, we can split at the @ and now we want to find this like test.email. So if it's a period without dots, this is just going to be, oh, and then plus Alex, it's ignored. So this is test email LeetCode, and then test email. Oh, and then dot Kathy. Oh no, wait. Oh, everything after the plus is ignored. Okay. So what if we first one we split by the @ symbol. Then I think we should try and see if there's any. We should split until plus if it exists. And then maybe we can split by period and join. Split by period and join. Honestly, you probably can. That's a good point. But how do you write the regex for that? That's one thing I don't know. I can do like simple regex, but like being able to ignore things. Maybe we should just look it up. Let's see, regex. That will be more valuable, right? Regex ignore after character. And it appears to work well. If you want to get everything after, excluding the set character, let me see, regex for remove everything after. And remove everything after a certain character. Do a find and replace with this regex. Email.pass. So is it just this? Okay, wait. I'm actually super happy that you said that, Manoj, because this is going to be more valuable, teaching us about regex here. So if I do this, let's take one of these emails here. So what if I want to do, this is escaped character. Do I just like escape this? Oh, okay, but does that mean that I want to actually just capture everything before that? Let me see something real quick. Let's see. Let's go to console here. Let's try this out. Like if I take this, const reg equals new regular expression, say G. So if we do, what do we have? What do we have here? Not last index. Exec flag source sticky Unicode. Let's actually look at the object regex p in JavaScript. Instance methods. Executes a search for a match, test, performs match to given strings, and returns match result. To change the data format, string replace, to split lines using can we just do like exec? Or what does that do? Exec. re.exec on a word. What is that? Does that return anything? Okay, so if we do reg.exec on this. Okay, so we get the thing it matched on, but what if I want like not everything that it matched on? Okay. Tricky part is the domain. And remove everything, or remove all characters after certain match, ignore. How about like regex get, how about get all but ignored or something? Match everything but a specific pattern. Any empty toString not starting with foo. This is a little more complicated. Starting with foo. How to match but not capture. You were mentioning the domain. Oh, is it because the domain, LeetCode.com, LeetCode? Oh, wait a second. I see. Testmail, LeetCode.com. LeetCode.com, 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 ABB, okay. I feel like we definitely should split in the beginning. That's like one thing that we could do. So let's start like writing this slowly here. Let's say unique emails. We can make this a new set, right? We can say for const email of emails. Inside of here, we can do const. I can say host and domain is equal to email.split at the @ symbol, right? So here we're just using like this @ and we're doing destructuring because this should give us back an array of length 2. So now this should give us a host string and a domain string. This is just like the beginning. Now we can try and start doing Like, I think the next thing we should do is for the host, we only want the part, like, can I slice? I might be able to also do like mdn slice string up to a certain character. I can't go up to a character. Slice, shift, splice. We could do this, but then that's like a double. Regex is definitely the way to go here. Because here we're like pretty close, right? I just need to get Alex LeetCode test email. Anyone know how to do like the negation, like regex or negation? How to negate? A great way to do this is to use a negative look ahead. Okay, negative look ahead construct is a pair of parentheses with the opening parentheses followed by a question mark and an exclamation point. That didn't do anything. Do I need the dot? No. If it matches, the result is discarded. Unless performance is of utmost concern, it's often easier just to run your results through a second pass, skipping those that match, okay? Or look behind. About regex parts of string that don't match. What part of a string that doesn't contain a word? I guess that's going to be the same thing, right? Okay. Negative lookarounds. That a break not containing. Do I need like a double? Nope. I was really happy to have like just that first part right there. I was like, oh, that's pretty cool. Regex is definitely tricky. But if not, like, let's see if we can solve it the other way. So what is it that I want to do? I just want to consider, I mean, for any one of these, right? For both of them, let's see. For the host, what I want to call this, like non-ignored host, or parsed host is going to be equal to host.slice from 0 to find index. And that's not even going to be, we need to do array.prototype. Oh, I can't do this on string. Are we, oh, we're not even guaranteed to have find index of, last index of, match, normalize. I just want to do the same thing again, like from host.slice to host.index of the first one if it's not 0. Plus sign index equals host.index of plus if plus sign index not equal to -1. Maybe here, maybe I should make this a let. That way over here, I can do something like host equals host.slice from 0 to plus sign index. All right, so like here, let's say in this first example, now I should just have test.email. Okay. And now here it says that's just connected. Could we just do const split host equals host dot split by period if split host dot length is greater. If it's greater than 0, then we can say host equals split host. And what does that actually look like? If we have hello world let str dot split by period. Now can we just join that? Let's split dot join. We could do that, but that also seems, I mean, I guess I can also just do a replace. I don't even need to do, yeah, what if we just do string dot replace all with the space hello world, and if it doesn't have them, str equals hello world string dot replace all. It'll just return the same thing anyway. So I guess we can just assume it's there, and we can say host. Let's see, host equals host dot replace all periods with string. So let's see what we have here so far. We have host and domain for this first one. Plus sign index will go up to here. So now we have test email. Okay, and we just replace everything. So we just have test email. That's the new host. And now we just have to figure out the domain. Now, LeetCode.com, like this is, oh, well, can a domain ever have, given an array of strings? Oh, but wait, the .com doesn't even necessarily need to be, it only needs to go into the last one. I think by using replace with regex, it can work. Yeah, it probably can. I don't think that if we had a plus symbol, okay. Part, note this rule not apply. Note that this rule does not apply to domain names. Okay, but here though, test email. Oh wait, do we have to worry about the domain at all? The domain is just that, like the domain doesn't change. Not applied to domain names, not applied to domain names. Oh, so these are only hosts. Wait, so then do we just do unique emails dot add? What if I just do host at domain? For const email of emails. Let me just see what this gives us. Return unique emails dot size. I think that's just an instance property. 2 and 2. How about this one? Next one. Okay, pass both test cases. Is it gonna work, guys? I wish there should be a thing where like we can have some sort of like drum roll or like a button on the stream that people can like, something that you guys can type, and I'll do like a drum roll on the stream. Like that'd be funny. All right, let's see if it passes. All right, 40.19. That's cool. I'm down for that. But now we should definitely look into regex for sure. We should look into regex for sure. 55.34. New set host domain email.split. Host domain plus sign index host.index of. So like, what is it that I need? I just need to get, never even heard of it. There's got to be a way to do this better. I really want to figure that out, because that gives us what we want. Why can't I just, and there's nothing else on this regex that I can get. Regex.exec. What if we did like reg dot Last index of what? Last index? What is last index? Oh, is that that's not even a, okay. Compiles a regular expression, no. Test to string, performs match to given string and returns match result. Match all, replaces a match in a given string with new substring. Oh, specifies how replace all should work. Oh, these are symbols. I can't even. Let's spend like a couple more minutes looking at negation. Like, match all except specific word. Essentially, that will match any input that does not contain the text. Ignore this. Okay, but like inside this. So is this saying like inside this I need another expression, right? Like in my head I'm thinking like, well, should it just be that thing? Can I put like another, can I put another thing in here? It doesn't like this one, unmatched opening parentheses. Oh, the last one. Oh, but, oh wait, that last one was where? Ignore this. Oh, so it should be right before the period. Negative look ahead specifies a group that cannot match after the main expression. How the main expression works: match all except a specific character. Match all except a specific pattern. Match all except a list of patterns. How about this one? Let's not forget what our original pattern was here. This was the pattern right here, right? So the original negative look ahead was what? Dot star, and then this is the pattern. Oh wait, can we do this? What if I just copy these three, because that kind of looks, oh man, okay, wait. If I did plus dot star, nothing. There's got to be a way to get the piece that we don't want, because then we can just get test.email. And we already have the domain, so I don't even care about that piece, right? I just care about this. How about regex match all but regex? Match everything but a specific pattern. Foo, match everything but a specific negative look ahead. String provided. How to match everything except a particular pattern. You could use a look ahead assertion. Yeah, that would be the best way to continue with this, right? I mean, I'm not too disappointed with the solution. Let's see what we got here. 81.75 plus sign index host.index of. So we split it, and then we got the plus sign index if it even exists. If it does, we just slice everything from the beginning to the end, which the nice thing is that regex would actually handle it for us. What if I just tried to do, I mean, if I greedily sliced it, like if we did let str equals Raphael plus Paola. If we did string dot slice from 0 oh no, yeah, that wouldn't work, right? I can't just go up to like any arbitrary one. Not sure. Super curious though, but let's move on to maybe like another one and see. Apparently this is the end of page 2, but I know for sure. Did we really finish page 2? Have we really finished page 2? I mean, there's a lot of them that we skipped. But that's pretty cool. I mean, we finished page 2. Let's see what this one is. Given a 0 index integer array nums, find the leftmost middle index, i.e. the smallest amongst all the possible ones. A middle index is an index where nums of 0 plus nums of 1 plus nums of middle index minus 1 equals, okay, I see. Oh, all the numbers on the left should equal all the numbers on the right. Pivot index. Yeah, I think this one, I think a good way of doing this one is we can do like a prefix sum almost. And what I mean is we can have, what if we had like 2 arrays? So this top one right here is going to represent the bottom. This is 2, and then this is 5. This is 4, plus 8 is 12, plus 4 is 16. And we have 4 plus 8 is 12. Right, and then at the same position, right? Like if we were now coming from the other way, like 0, 0, 0, 0, 0. Right, this first one would be 4, and then here 8, that would be 12. And now you can see these values both match up right here. For this next one, what would we have? We'd have a 1, we'd have a 0, and then we'd have a 4. 0, 0, 0. We add the first one. That's 4. It does match this index here in the end. We get that. For 2 and 5, we have a 2 and a 5. That's 7. And then we have a 5. We never get a match, so it's 0. Or rather, -1. So I think what I want to do is I want to create... Now, I know there's a way of doing this with like one array. I don't necessarily need to even... Right, because if I just have these two things... If I do 16 minus 4, that's 12. Or what if we do 16? Yes, 16 minus 4, but then how do we get the 8 here? Would it be because we're doing 16 minus 4 and that's 12? Does that necessarily mean it's 8? Here we have 4 and 4. We can try with 2 arrays. 4 and 8. This is all the numbers up until 16. Like this one represents the addition of all these numbers, including this one, right? 2 plus 3, 5, 4, 12, 1. If I'm going this way, if I'm at the 0, I haven't added any yet, but I know that everything else gives me a 16. That's a 4. So I should subtract 4 from 16. Now I get to 8. Oh, if I subtract 4 from 16, that gives me this number, which is 12. If I subtract 4 from 4, that gives me this number, which is 0, but that's not, but they're already both the same. So I don't think I necessarily want to do, if I subtract 4 from 16, that's 12. So I come here, this one's 12. If I subtract 4 from 4, that's 0, but that should already be the one that we're at. So let's just do prefix sums. Let's do prefix sums from the left and prefix sums from the right. So const left prefixed is an empty array. We can say for let. I guess we can just do, yeah, for let I equals 0. Do I even need that one? I guess I can just do 2. 3 plus 2. I can just make this one nums of 0. I could just start at 1 here and go from nums.length I plus plus. Here I want to do left prefix dot push the current I plus left prefix of left prefix minus 1 for the previous one. We should actually just be able to go to the previous I, right? Left prefix 1, and we can just do I minus 1. So we're going to do nums of I. So we're going to push nums of I, which is 1, which is 3 plus left of prefix of 1 minus 0, which is 0, and that's the 2. That should give us the 5. That's what left prefix will do. And now const right prefix. What's like the best way for me to do this without having to like shift so many characters over? Yeah, no, we gotta figure out how to do this with a single array. There's no way we need to do this with 2. 2, 5, negative 4. No, 4, 2, 5, 4, 12, 16. So like any one number here, so we can say that the mid index, the nums at mid index is equal to what? Would it be prefix sum at I minus right? Like something like this? Kind of weird. I'm just like, prefix sum, like if it's 12 minus right, if this is 0, 16 minus 0, because like we're here, let's say, then we get to 12 minus 4 is equal to this, okay. 16, 4 minus 0 is 4, and that's the same one. 12 minus 4 is 8. Here we have 4 minus the 0, which is 4. So it's that last one right there. I think maybe we can do something like this. Do I have a CS degree? So I actually went to music school, but I did, like I was in a music school, but I took engineering classes while I was in music school. But I don't have like an official computer science degree, but I got a degree in audio engineering. But there was computer science involved, but I wouldn't say as heavily as computer science or computer engineering students. But I do have a bachelor's of science. So hopefully that answers your question. I almost kind of want to use this somehow to my advantage here. Because what if we just go, oh, Ableton or FL Studio? I mean, honestly, man, I never got it. So I'll tell you briefly, like I went to audio engineering because there was a specific school I really wanted to be in, and I got to the school and everything was great. But I quickly realized that the students in audio engineering were very interested in audio engineering, like being able to produce music, being able to learn about like speaker design and digital signal processing and acoustics and all these things. But I quickly found out that I was more interested in learning about like C++. So my advisors were very cool, and like for any like audio engineering specific class that had a similar level course in the College of Engineering, they allowed for me to replace it. So what do I mean? For example, we had a course for acoustics. I was not interested in acoustics, but I think acoustics was like a 300 level course, and operating systems was also a 300 level course. So I was just like, can I just replace acoustics with operating systems instead? And I was able to do that. So that's kind of like what I did. I just started doing a lot of a la carte classes from College of Engineering, and I was like just having a lot more fun with that. I guess I'll probably say FL Studio though, only because I messed around a lot with FL Studio when I was younger, to answer your question. Or Logic is pretty cool too though. But like, there was like, let me see if I can find it. Will Perkle audio C++. Like my professor like wrote this book right here, Designing Audio Effect Plugins in C++ with DSP theory. Like it's pretty amazing. Like this is the type of stuff that we were learning. We weren't, people just think like, oh, you're just learning how to like be in the studio and like mix. Like this degree, like you were learning about how to even write your own audio effect plugins. Like I had a class where I was able to build my own chorus pedal, and then I was also able to write C++ to make a chorus effect. So it was like, it was very, very cool. Oh, and Juice Framework. Yeah, I have heard of Juice Framework. That's very cool. Okay, so let's think about this. I feel like I'm getting a little bit sidetracked here. So I'm gonna say my right here is 0, and what do I want to do? Like, is 16, right? Like, if, and let's say I equals nums.length minus 1. If right, or if I minus right is equal to nums I minus right, if I, no, the right is going to equal this thing. 12 minus 4 is 8, 16. So I, if prefix of I minus right equals, if prefix of I equals nums of I, return I, else right plus or equals nums of I. Okay, I know this looks like a crazy algorithm here, but let me sort of like distill this. So this is like my prefix sum, right? So I can start a pointer like out here, which consequently is the same pointer that would be in nums, and I can set my right equal to 0. So I say, is prefix of I, is 16 minus 0 equals to 4? No, it's not. So now we can go down 1 here, down 1 here, and I can add 4 to my right. And I can say 12 minus 4 is 8. So I can just return nums of I. It's kind of what I'm thinking. But yeah, maybe something like that. So let's see if this works. For let, so we can say let right sum equals 0. For let I equals nums.length minus 1. I greater than or equal to 0. I minus minus. If, and instead of calling this left prefix, let's just call this prefix. So here we'll say if prefix of I minus right sum is equal to nums of I, return nums of I, else right sum plus or equals nums of I. Return nums of I, or just return -1. I'm glad we were able to have that conversation about all these different like DAWs, right? That's what they're called, digital audio workstations. Okay, so let's see. Let's like, I'm just gonna run this, see what happens. See if we at least get the first one right. Ooh, wait, what? Prefix.push nums.length for let I equals nums.length minus 1, I greater than or equal to 0, I minus minus, right sum prefix.push nums of I, but there's probably something over here that I'm messing up. 0, 0, 0, 2. What if we just do like prefix is new array of nums dot length dot fill 0. And let's do, so now we can say for let I equals 0, I less than nums dot length I plus plus. We'll say like let sum equals 0. Here we can say prefix maybe sum should just equal to nums equals 0. Prefix at I equals sum plus or equals. Why is this always so hard for me to figure out, like a prefix sum? I want to do 2 this plus the previous one. So if I just make previous, if I start at here, I should just be able to push this plus the previous one. It's amazing how like something like this that should be so simple can sometimes be like the hardest thing. You just get to like a brain fart and it's like hard to figure out. The previous sum is 0. I'll do 2 plus 0 and I'll set this to be, yeah, let's do that. So let's sum equals 0. Sum plus or equals nums of I. Prefix of I equals sum. Right, so sum plus or equals 2, that's 2. Sum plus or equals 3, that's 5. Sum plus or equals, okay, cool. Is this gonna work now? Output 8. Wait. Oh, they want me to return the I. Three and 3. Let's run this one. 3, 2, -1, 3, 2, -1. Is it gonna work? Let's submit it. 0, 0, 0, 0, 0. How did I get 3 here? Wait, but isn't that the first one? Oh, return the leftmost middle index. That's beautiful. So should I just go from... Wait, then can't we just do this starting from the right? I feel like I just wasted a lot of time because I was assuming it's from the right. I think I can just do everything if I just essentially like flip it. I take a prefix sum starting from the back here. Could that work? Let's do const prefix equals new array nums dot length dot fill 0 for let, and we can say let sum equals 0 for let I equals nums dot length minus 1, I greater than or equal to 0, I minus minus. We can say sum plus or equals nums of I, and prefix of I equals sum. Let's just log this out real quick. Console.log prefix. I should now have a prefix from the left. 4, 12, 11. Okay, that's cool. And now what if I just do the same thing, right? But from the left. So I can say let left sum I equals to 0, I less than nums dot length. Let's see if prefix of I minus left sum equals nums I, left sum plus or equals nums I. I haven't even ran it in my head, but let me just see what this gives us real quick. Is it gonna fail again? Oh wait, I plus plus. 2, 3, 8, 3, 2, -1, 3, 2, -1. Okay, let's see our submission for this one. Are we gonna get our 0? Okay, submit. Hey, awesome. Okay, sweet. Like, two things I like a lot about this example here. So the cool thing is, like, I almost always solve these questions using 2 arrays, but I think just getting away with doing 1 was really cool, and trying to figure out that formula for figuring out, like, essentially this piece right here, I think that helped a lot. Right, like, this is exactly why I do these streams, because you all just saw me, like, not only did you see me, you heard me struggling with this question, thinking of like random things. So I hope that's valuable to you all, because it's one thing for me to just make a video and show you, oh, this is how I do it, best thing, awesome. But I hope that like by you hearing me all like talk about all the different things I'm thinking of, that might get you to also think like, oh, maybe that's something I should think about for next time. So that's like essentially why I'm doing these streams, and I really truly hope it brings value to all of you. And then the cool thing is, like, I was doing, like, previously my solution was from the right to the left, right? All I did was just flip everything, and I started from the left to the right. So that's pretty neat. And I think this will be a good place for us to stop, because according to LeetCode, we're done with page 2, which is incredible. So we're gonna start doing page 3. You know, the crazy thing is there's still so many questions here that I know are like super, super top quality questions that we haven't even gotten to yet. Like, let me see if we can find, is there any one of them here that I know for sure is like really good? Oh, binary tree post order traversal, that one's gonna be really nice. Leaf similar trees, that should be pretty good. Yeah, like I definitely feel the difficulty increasing. So that's pretty awesome. Okay, sweet. Yeah, we've gone like almost 2 hours. So I think usually only my weekly roundups are this long, so it's pretty cool that we've managed to like go this far. Let me just check something real quick here. Let's go YouTube Studio. Yeah, I like Fallout, if you guys didn't know that. I don't know if there's anything else anywhere that says why I like Fallout so much, but I listen to like the Fallout radio on YouTube. So we're going live. We're still live here. Okay, sweet. Okay, awesome. Well, thank you all so much for joining. I'll make sure to edit this video. And when I say edit, I'll put all the chapters. I'll make sure to add all the questions that we did that we liked. Like this one that we did right here, I think this is a good one. I'm going to add this here. If you like what you saw, if you like what you heard, remember to subscribe to the channel. Remember to ring that notification bell if you want to see like real time when I go live. Remember that I'm constantly updating rafaelslist.com. So it's just like a good place for you to keep track of all the different questions that we have. And of course, with the new feature to be able to keep track your progress, it's something that a lot of people have wanted. So I'm glad that now we can at least support that. So again, thank you all so much. And I hope to see you all in tomorrow's stream. Have a great rest of your Monday. Happy coding, and see you all next time.